My presentation today will cover 5 main parts, and I will start with the current status of e-bus in China. And as we all know, China is in the leading position of electrification, and I will explain a little bit about how and why China became the leading country of the electrification and what is the major driving force. And then I will share some e-bus operational data and charging infrastructures. And at the end of the presentation, I will use Shenzhen as an example to share some successful experience from the first 100% electric bus fleet city. Can you go? Yeah. China started new energy buses promotion from 2009, and the number of new energy buses increased rapidly since then. Till 2019, the total bus fleet in China is 693,000, and new energy buses, which account for 59% of the total bus fleet. So in China, the new energy buses defined as BEB, battery electric bus, hybrid, and fuel cell buses. And in all the new energy buses, the BEB accounts for 70% of the whole fleet. So this is a graph showing the different bus fleet, the different number of buses owned by different regions because of the economic status and the climate difference. So different regions of the country have different progress and owns different numbers of buses. We can see from the graph that cities in South China and East China have much higher number of new energy buses, and followed by city in North and Central China. And the number of new energy buses in the city in the West, Southwest, Northwest, and Northeast regions are still relatively small. We can see in the city of Shenzhen, Guangzhou, Zhengzhou, and Changsha, the new energy buses are account for more than 90% of the whole bus fleet. So this is the 36 major cities in China, and which is the most important cities in China. We can see the different numbers of new energy buses and also the traditional buses. So here we can see more than 13 cities in these 36 cities have owned more than 50% of new energy vehicles in the whole bus fleet in the city. And we can tell that in Zhengzhou and Guangzhou, Shenzhen, and also Changsha, which has already achieved 100% electric or new energy buses. So in more than 10 years promotion, the national government and local government provides tremendous support to the electrification. And there are 4 most important driving force for the progress, which is policy support, e-bus industry, environmental pressure, and infrastructure. Hereafter, I would like to explain each one into detail. So we summarize the most important and the relevant policy documents since 2009. China started electrification with pilot program in pilot cities in 2009. At the very beginning, China initiated a program called 10 cities, 1,000 buses, which means that in a few cities, the government will provide subsidy for the electrification. And later on, more cities were selected in the program, and then the promotion is expanded to the whole country. The electrification in China started from urban public sector vehicles, such as taxis, buses, inner city delivery buses, and TNC vehicles and sanitation vehicles. So in a state that our President Xi Jinping stated that the development of new energy vehicles is the only way to move China from a large automobile countries to a powerful automobile countries. So this statement pushed new energy vehicles to play a essentially prominent role in China's 7 strategic industries. Can you go to the next? Yeah, and the next. So I'm not going to the detail of the list of policy documents, but this is the historical policy document for electrification in China. Can you go to next? So the national policy is the most important driving force for e-bus promotion. We can see from the graph that from 2013 to 2016, the local government provides tremendous subsidy for e-bus procurement. For instance, if a city wants to buy a 2 million RMB 12-meter buses, the national government will subsidize 500,000 RMB, and the local government will provide the same amount. So the bus operators only need to pay 1 billion RMB for the bus procurement, which is a similar price with the ICE buses. And from the chart, because in 2016, the government has shifted the bus procurement subsidy to provide subsidy on operation and also on infrastructure construction. So from the graph on the left, we can see there's a drop on e-bus sales in 2016. And I didn't have an exact number for the e-bus sales during COVID period, but in March 2020, the national government announced economic stimulus plans for new infrastructure plan, which the charging infrastructure is one of the 7 main fields. And the government decided to invest more than 20 billion RMB in the charging infrastructure construction, and also the subsidy of the bus procurement and also for the operational will continue to next year. So this is a chart showing that how subsidy policies has been developing and improving. Before 2016, we can see that the vehicle length is the only indicator for claiming subsidy, which caused a lot of problems that many cities are cheating on subsidy, and many bus manufacturers are making fake numbers or making very poor quality buses. And also the bus manufacturer and operators will produce and purchase small buses to get more subsidy rather than to meet the operational requirement. So later on, the government, which gained experience and learned from lessons, since 2016, more indicators are taken into consideration. We can see from the chart that from 2016, the energy consumption per unit load and also the energy density has been taken into consideration. And also the subsidy setting up are paying more attention to vehicle and battery technologies. The industry also helps to push the electrification forward. The cities, while the top 10 bus manufacturers located own the largest new energy buses proportion, we can see with the support of Yutong, BYD, and Zhongtong and Yinlong, the development of electric bus in the cities have accelerated. And we can see from the chart that Yutong in Zhengzhou and BYD in Shenzhen and also Zhongtong in Changsha will be soon achieve 100% of electrification in buses. And those cities are the leading cities in electric bus development. So this is a graph showing that the most severe air pollution areas, the national government set very ambitious and restrict targets for those cities to achieve electrification goals. And in the provincial capitals, the national government announced a policy that till 2020, all the buses has to be new energy buses. So they have all the capital cities need to purchase more buses in this year to achieve this target. And I would like to show some operational data. And the first of all, that's a very important operational e-bus performance data is the daily average driving distance. We can see from the graph on the left that although the daily driving distance in 2018 has increased from 2017 and 2016, which is 123 kilometers, but this is still much lower than traditional buses like diesel bus. The average daily driving distance is 2,208 kilometers. And from the graph on the right shows that different average driving distance for different cities. Guangzhou has the longest daily driving distance, which is 185 kilometers per day, which is still less than traditional bus. So there are many reasons. There are many reasons to lead in this result. First of all, the operators didn't use the e-bus for the whole day operation because they worried about the driving range. They had driving range concerns. And secondly, because when you operating an e-bus, there are more factors to consider, and you have to optimize your dispatching plan, and also you have to make a new charging plan. So very few cities did that in China, and the city didn't make full use of the e-bus. So in many cities, the common situation that is they need more e-buses to replace one traditional IC bus. And the second is cities don't have enough charging infrastructure. The e-bus and charging infrastructure ratio in China is about 4:1, and more than 98% of the chargers are depot plug-in chargers, which means at night, like buses needs to queue or needs to wait for charge. Here are more operational data. The first one showing the e-bus size. 50% of the e-bus in China now are more than 12 meters long. And also from the second one, we can see that the daily operational time for e-bus is only 8.36 hours in 2018. As I mentioned earlier, because the city doesn't have a optimized operational plan, and the city doesn't have enough charging infrastructure, so the operational time for e-bus is much lower than traditional ICE buses. And we connect data from 5 different cities about the daily driving distance of e-bus compared with ICE buses. And from the driving distance, we can tell that more e-buses is needed to replace the one ICE buses. For example, that in Beijing, we need 2 e-bus to replace 1 ICE buses. And also in Wuhan, we need 1.9 e-bus to replace 1 bus. So that's a common issues in China, in many cities in China, that we need more e-bus to replace 1 traditional buses. So we have to solve this problem. And this year, ITDP is helping the city to develop an operational assessment system. In that system, we will compare all the operation, we will connect and analyze all the operational data and to show the gaps of the e-bus from different cities, and make an evaluation system for cities to improve the operation or improve the charging plan. Can you go to the next page? Yeah. Here are some data connected from different buses, different bus type from different bus manufacturers. So energy consumption varies in different weather. So in winter and summer, the power consumption is much higher than in spring and autumn. And especially in winter, e-bus consume the largest electricity per kilometers. And this data shows 7 different bus types, the energy consumption for 7 different bus types in Beijing from March 2017 to June 2018. And all these bus types show the same trend of the weather, the energy consumption varies because of the weather. And the result is that 8-meter e-bus consume 56 kilowatt to 78 kilowatt electricity per 100 kilometers. And for 10 meters e-bus consume 98 kilowatt to 1,004 kilowatt electricity for 100 kilometers. Can you go to next page? And from this graph, we also can tell like the energy consumption for 8-meter e-bus from different manufacturers. There are 4 bus types from 3 different bus manufacturers. The first one is from company A and C. The second and the third is from company B, and the last one is from company C. So from this graph, we can tell that the bus A and bus C is the most energy efficient buses. Doing this data connection and analysis will help us to make the decision when choosing e-bus from different manufacturers. And more energy consumption analysis is showing in next slide. So energy consumption varies in different geography. I don't think this is clear enough to show that the energy consumption, this is the energy consumption for the same e-bus in different cities. Here I want to emphasize the green line, the red line. This is from the energy consumption in Harbin. We can see that in winter, the energy consumption is much higher than the other season and the other cities. That's because Harbin is super cold in winter. So to connecting this data, like it is very important to tell the real world operational data and the e-bus performance. We can make better decisions when we choose in different types of bus in the local context. And we also did some operational failure analysis. Here we can see, compared to ICE buses, the e-bus has less failures. And from the data, like for e-bus, the operational failure is 0.5 per 10 kilometers, per 10,000 kilometers, and is 1.6 per 10,000 kilometers for ICE buses. And also the failure for battery, engines, and control system account for 63% of the total failure, which means that we need to have experienced technicians to work on the maintenance, and also we need to build the capacity for the workers in the operation and in the bus maintenance group. So let's go to the charging infrastructure. We have two different charging types in China. One is plug-in and one is pantograph. But in China, the plug-in is the most common and most matured charging technology in China, and which accounts for more than 98% of the whole charging infrastructure. So plug-in charger is cheaper to purchase and also cheaper to install, but less flexible, since generally cities have limited depot space. And with the plug-in charger, for instance, we need more space. Typically we need more than 80 centimeters to 1 meter space between the charger and the bus. And also we need more space for charger itself. Normally it will occupy 80 centimeter by 80 centimeter space. So we have to preserve more space in the depot for the charging infrastructure. And pantograph in this case is more flexible because we can install the pantograph charger along the bus route, which at the start and at the end of the station, and is more flexible, but is more expensive. Can you go to next page? So this is the pantograph charging infrastructure in Shanghai. This is the first in China as well. And it's installed at the beginning and at the end of the bus route. Pantograph charging can be a good solution when the corridor has a lot of frequency, has high frequency, such as BRT corridors. So I always recommend Chinese cities to consider a combination of plug-in and pantograph charging infrastructure. In this case, I think we can gain a longer daily driving distance, and then we can ease the concern on the driving range of e-bus in China. The national government also provides tremendous subsidy on charging infrastructure. Here is a graph showing how subsidy of charging infrastructure are related to electric vehicles in the city. And cities have to have certain number of electric vehicles to trigger the subsidy, and the subsidy has been increasing year by year. So I'm not going to the detail of the graph, but you can see that in 2016 the subsidy has been increased tremendously because the national government and the local government shifted the subsidy from purchasing the e-bus to the operational and also to the charging infrastructure. And because of the technology development and the improvement, we can all see that the price for DC charging power module has been dropped dramatically from 2014 to 2019. That we which explains that why Chinese cities have such a lot of depot chargers rather than pantograph charging infrastructure. But we need to change that trend because the combination of different charging infrastructures will help to make the operational plan more efficient. So based on what we have learned from China's electrification, we suggest that the national government and city and bus companies and the industry should work together. We should work together on establish a testing, evaluation, monitoring, and report mechanism on e-bus real-world performance. So there's a challenge in China that to get the real-world performance data is super difficult, and the bus manufacturers and also the bus operators are reluctant to share the real data because they don't want, I don't think because they think that's confidential, because the bus operator needs to use the data to claim subsidy, and also the bus operators doesn't want to show the real world operational performance data is different with the data they announced as a product. So that's been very difficult. And also all the stakeholders should work together to establish an e-bus monitoring platform to help them to make a better decision when deciding on e-bus, which type of bus from which manufacturers to purchase, and also to make a better decision on operation. And from the lessons learned or experience from Chinese cities, we think charging infrastructure should be planned before e-bus procurement. And also a combination of different charging infrastructure should be considered. And also optimized bus route plan and operation plan should be conducted before e-bus procurement. And also we need to consider different types of buses and charging infrastructures when we conduct detailed operational plan. I know that many cities in Brazil are considering initiate the e-bus plan, and I think China's experience can be useful. First of all, we have to start with a pilot project and connect and analyze the real-world e-bus performance data. And based on the analyze, then we can make the decision on large-scale expansion. Aiming to build an efficient e-bus system, we need to consider bus fleet size and schedule, battery capacity, grid capacity, and driving range, and charging unit and location, and also grid capacity when conducting route planning and charging plan. So once we have the pilot project ready, we need to connect and analyze the operational data. Can you go to next slide? Yeah. Which is very important to understand the real world operational situation and provide guidance on e-bus procurement and operation for large scale expansion. Those data are really important. First of all, is power consumption. And we need to have record changes in different temperature and also the driving range. The driving range in different temperature and in different geography, and performance review for e-bus from different manufacturers, also charging patterns and major operational failures and operational costs, and also monitoring the bus performance and the charging behaviors. At last, we need to calculate the benefit, the energy saving, the CO2 reduction, and the pollutant reduction. In the last of my presentation, I would like to share a case study, the electrification in Shenzhen. In 2009, Shenzhen was selected as one of the cities for the 10 cities, 1,000 vehicles initiative. And also finished the integration of several private bus operators into 3 large bus companies, which is Shenzhen Eastern Bus Company and Shenzhen Bus Group and Shenzhen Western Bus Company. In 2011, Shenzhen developed 2,200 e-bus, and the first fully electrified bus route was launched. And in 2015, the company developed, explored a new business model, which I will explain later. And also in December 2017, Shenzhen owns the largest bus fleet, e-bus fleet in the world. And the e-bus fleet in Shenzhen reached 16,000 and is the first in China and the first city in China and also in the world to fully electrify the bus fleet. So this is a chart showing the increase in the bus fleet, the number of bus fleets increase in Shenzhen. We can see there's a very big increase from 2014, 2015, and 2016. That is because at that time the government provides the most subsidy during the 3 years. Okay, yeah. In addition to national policy, Shenzhen also issued a series of policies to support the e-bus system. The government at all levels paid great importance to the promotion of electrification. Shenzhen set up a leading group for the promotion and application of new energy vehicles headed by the mayor. And the mayor will directly oversee the electrification progress, and many different departments are involved in the planning and implementation. So those departments including the Development and Reform Commission, which coordinate the local implementations and also receives direction from the national government, and Urban Planning, Land and Resource Commissions, which identify the suitable developed and undeveloped land and oversee locations for charging infrastructure, and the district government, which supports the provision of land permit for the charging infrastructure, and the Transport Commission, bus companies, and grid companies. So that's why all the different departments working together to make Shenzhen achieve the 100% electrified the e-bus fleet. Can you go to next? And this is the local national subsidy and local subsidy for Shenzhen. And Shenzhen has coordinated 5 billion RMB supporting funds for promotion and also application of new energy vehicles. We can see that from 2013 to 2016, the government provides like half of the cost for purchasing one bus. If the bus is 2 million, the government provides 1 million for procurement. And due to the high upfront cost, Shenzhen developed a system to integrating multiple parties to reduce the overall cost. So the financial model, a business model is called financial leasing and separation of vehicle and battery, outsourcing of charging and maintenance. I'm not sure if you can see clearly of the chart. From the chart, we can see that the financial leasing company will pay for the bus purchase and from BYD, and then the Shenzhen bus company will pay the cost and interest in 8 years, and then the leasing company will lease the bus to Shenzhen bus company, and also the bus producer will sell the battery to the charging and maintenance unit, and then the charging and maintenance unit will provide charging and maintenance service to Shenzhen bus company, and the bus company will pay the service service fee to the charging and maintenance company. And so this is a very successful financial and business model, which many cities are learning from Shenzhen, because the national government and the local government subsidy is dropping. So cities have to figure out how to meet the target from the national government. Then the financial model or business model will help them to achieve the goal, and even without the national subsidy. I think this is all of my presentation. So, and I hope I can provide some help for you city, and then welcome for any questions. Thank you.